Okay, Assalamualaikum and a very good morning to all our students. Okay, so today is the first lecture for the mathematics SM025 session 2020-2021. Okay, my name is Farid bin Saad. Hopefully that you are ready to listen and watching our YouTube channel KMKK Official. Okay. For today, we have a limit time, 1 hour. Okay, so hopefully that I can finish the time in time given lah. Okay, untuk this 1 hour, I will show the solution for the question, and that you can refer in our lecture notes, and that already given on. If I'm not mistaken, on Friday. Yeah, so please refer to the notes. Yeah, okay. The next one is not all of the question that we can show the solution. So if there is a question that we or if I don't show here, you can do it yourself or ask your lecturer. Okay, so we start our lecture for today. Okay, chapter 1, integration. Yeah, integration. So for integration, we have 4 subtopics. That is integration of functions, integration of trigonometric functions, techniques of integration, definite integral. Okay. Next, for the subtopic 1.1, integration of function, the learning outcomes at the end of the lesson should able to relate integration and differentiation. B, define the basic rules of integration. C, find the integral of e power of bx plus c, 1 over bx plus c, and a power of bx plus c. And D, determine the integral of the forms, as you can see that, 1 until 3 lah. Yeah, the first one is integrate to f prime x over fx dx. Yeah, the second one is f prime x times e power of fx dx. And the third one is f prime x times with fx power of n. Yeah, power of n. Okay. Next. Integration of a function, relationship between integration and differentiation. Integration as anti-differentiation, and integration is the reverse process of differentiation. Okay, the process of finding antiderivative is called anti-differentiation or integration. So for the semester 1, we already learned the differentiation. Yeah, there is d, for example, d over dx to the function gx, and then we get or solve or to get the answer is fx. But for the semester 2 integration or anti-differentiation, we take the differentiation answer, that is fx, fx here, we integrate it. We integrate it and we get gx, the original function that we differentiate earlier. Okay, so the last one, we have to put c at the end of the answer. What is c? C is called a constant of integration. Basic rules of integration. Okay, there is 5 basic rules of the differentiation. The first one is integrate to k dx, so we get kx plus c. The second one is integrate to x power of n, and dx is equal to x power of n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. The third one is k fx dx. We can simplify or put a k outside of the integration, and then we get a k integrate fx dx. Number 4, integrate fx plus or minus dx dx is equal to integrate fx dx plus or minus integrate dx dx. That means if we have the integration, we can like this one, we can separate it. Number 5. Number 5, integrate fx power of n dx. Okay. And now, if you look, what is fx? Fx is a linear function. Fx is a linear function. That means, for example, fx is equal to x power of 1 plus 1. X power of 1. So it's linear. So we can use this formula or rules. Okay. So what is the rules? Fx power of n plus 1 divided by n plus 1 times f prime fx plus c. So please remember, fx is a linear. So we can apply the formula. Okay, next. Okay, example 1. Find the following integrals. You can refer the notes. So integrate to 3 dx. So what is the solution? Before that, what is the basic rule that we use for this one? There is the first rule. Okay, the first rule. So what we get? So integrate 3 dx, we get equal to 3x plus c. But please not forget to put c to the end of our answer. Okay, next. Integrate x power of x dx. So what is the solution? Okay, so this one we use the second basic rule, where the power with plus 1 and divide by the power. So that means x power 6 plus 1 divided by 6 plus 1 plus c. So we simplify it to x power of 7 divided by 7 plus c. Okay. Next, integrate to 1 over sed x dx. So in basic rules, it doesn't mention that in a form of 1 over something. 1 over something, but we have to simplify it. For example, here, when integrate 1 over sed x dx is equal to, we simplify it, we bring the denominator sed x to the numerator, so we get x power of negative 1 over 2 dx. So we can apply the second rule. The second rule, that is x power of negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1 plus c. Please don't forget to put c after we integrate it, and then we simplify it 2 sed x plus c. Okay, next. Next. Example 2. Find the following integrals. Example 2, I take b, to see what's going to happen when we have integration to fx that has a power. Okay, so integrate 3 times 2y plus 1 power of 2 over 3 dy. Okay, 2y plus 1, as you can see, it is a linear function. It is a linear function. So how we solve this one? Okay, so 3 times 2y plus 1 power of 2 over 3 dy, we can bring 3 outside of integral symbol, and then we look at the power, and we can use the second rule, that is 2 over 3 plus 1, and then divide 2 over 3 plus 1. And then don't forget to differentiate dy plus 1. So we get 2 here. So you can simplify this one, and then don't forget to put c. So I think this is the final answer for this PowerPoint. Okay, so please simplify this one. Yeah. Okay, next. Okay, C. Integrate 4x plus 1 over 2x cubed dx. If we refer to the basic rules, if we refer to the basic rules, we don't have the rules that mentioned for the denominator with 2x or x is more than power than 1. So this one is we have x power of 3. So what we have to do with this question, we separate it. Yeah, as you can see here, 4x divided by 2x cubed. Yeah, we separate it 1 and then we get a 2 over x squared dx, and then plus 1 over 2x cubed. 2x cubed dx. So this one we can use the basic rule number 2, for 2 over x squared. That means we have to bring x squared to become a numerator, so the power become -2 lah. -2, and then 2 we can put outside. So 2 integrate x power of -2 dx plus another one 1 over 2 also we can put outside outside of integral form. And then bring x power of 3 to the top, we get x power of -3, so dx. Hopefully you understand how to form this one. And then we use the second basic rules. That is, we get 2 times x power of -2 plus 1 divided by -2 plus 1. Plus 1 over 2 times x power of -3 plus 1 divided by -3 plus 1. And then please remember that we only put one c, one constant here. Plus c, not 2c, not 2c. There's only one c. Even we have to integrate 3 terms. For example, this one, we have separated it in 2 terms. This term and this term. Then we have 2 terms. So even we have to integrate 10 terms also. We have only put one constant, plus c here. And then we simplified it. We get -2 over x minus 1 over 4x squared plus c. Okay. Please screenshot if you have a problem to understand it. Okay. Next. E, integrate to x power of 2 plus 5 power of 2 dx. Okay, if you want to use the formula basic rule, which one I already forget about it. So please remember that in bracket there is a quadratic function. Quadratic function here. So we cannot use the formula. What we have to do is simplify it. What I mean simplify it, we have to expand it. Expand this one. So it become like this one. Become x power of 4 plus 10, x power of 2 plus 25. Okay. And then we differentiate it for the every terms. Okay, like this one. Integrate x power of 4 dx plus 10 we put outside. Integrate x power of 2 dx plus integrate to 25 dx. Okay. If you already mastered the formula or the integration, you can skip the step. Or this one, you can just go ahead, use the formula. For example here, x power of 4. We integrate x power of 4. 4 plus 1 is equal to 5, and then divide by 5. Okay? And then plus 10 power of x power of 3. How? X power of 2, 2 plus 1 divided by 2 plus 1. 2 plus 1. Okay, plus 25. 25 what? 25 x power of 0 actually. 25x power of 0. 25x power of 0, that means 0 plus 1, so we get 1 divided by 1. So we get 25. And then the final answer, please don't forget to put plus C. Yeah, plus C, that means constant lah. Okay, next. Okay, there is a special case when we integrate where the power of n is equal to minus 1. For example, x power of negative 1. Yeah, x power of negative 1. So if we apply the second basic rules, when n is equal to minus 1, plus 1, it becomes 0, and then divided by 0. So we cannot conclude what is the answer. So the solution is, when integrate 1 over x dx, 1 over x dx is equal to ln x plus c. Yeah, why? Why is it become like this? Yeah, remember that when we differentiate ln x, differentiation is from the semester 1. When we differentiate ln x, is equal to 1 over x. Yeah, so when integrate 1 over x, we get ln x. Yeah, we put absolute here plus c. Okay, so this one is a special case when n and the power is equal to minus 1. Yeah, minus 1. Okay, hopefully you understand that one. Okay, next. Okay, the integral of e power of bx plus c, 1 over bx plus c, and a power of bx plus c. First, we look at the integral of e power bx plus c. Okay, as we differentiate e power bx plus c, what we get is b times e power bx plus c. Okay. Okay, so therefore, when we integrate e power bx plus c, dx is equal to e power bx plus c plus c. C, this one is a constant. This one is a constant, and divided by the b. Where is b? B is a differentiate from the power of exponent. Yeah, we differentiate this one, so we get b. Yeah, don't forget this one. Okay, next. The integral of 1 over bx plus c. And that means integration to the 1 over bx plus c. Okay, there's a note here. Remember that when we differentiate, for example, differentiate to ln 1 plus 3x, or ln 1 plus 3x. So what we get is 1 over what? 1 over, after ln, what we have here? 1 plus 3x. That means 1 over 1 plus 3x. And then don't forget to differentiate. Let's say this one is a function. Differentiate the function after ln, we get 3. And that means differentiate ln 1 plus 3x, we get 3 over 1 plus 3x. Okay, please remember this one. And then if we integrate 1 over 1 plus 3x and dx, what we get is 1 over 3 ln 1 plus 3x plus c. Yeah, so please remember this one. In general, if we have to integrate 1 over fx dx, we will get 1 over a. What is a? A is mean that we differentiate fx. We differentiate fx, so we get a, and then times this ln to the function fx plus c, where fx is a linear. Linear. Okay, fx must be linear. Okay, next. So the integral of a power of bx plus c. Okay. This one also have a note. Yeah, when we differentiate to the a power of fx. Fx is the power to a, where fx is a function in terms of x, plus b. B is a constant or integer, is equal to a power of x times ln times f prime x. Yeah, so this one is a basic differentiation lah. Yeah. Okay. Therefore, when we integrate a power of fx dx, when we integrate a power of fx dx, what we get is a power of fx, that means itself, a power of fx dx divided by ln a. Ln a, what means a? What is a? Is the base to the fx, a base this one. So then we multiply with the f prime x, f prime x multiply. So plus c. Again, don't forget to put c at the end of our solution. Okay. Next. Example 3. Find the following integrals. Integrate 2 power of x dx. Yeah. There is base 2 here, and the function fx is equal to x. Yeah. You can use the formula if you remember about it. So integrate 2 power of x dx is equal to, what we get, the question itself, fx, 2 power of x, divided by ln to the base. What is base? Base 2, ln 2, then differentiate the power. Differentiate the power, we get 1. 1 here, we cannot multiply with number 2 here. We have to put in the front of the ln. Yeah. So for the answer is we look, it seems there's no multiplication for the ln 2, isn't it? So actually 1 exists. 1 exists, we put at the front. Okay, so don't forget to put plus c for the final answer. Okay, next. Integrate 4 power of 2 minus 3x dx. Okay. Solution. When we integrate 4 power of 2 minus 3x, 4 power of 2 minus 3x dx, firstly, don't forget to put 4 power of 2 minus 3x dx, and then followed by or divided by ln to the base. So ln 4. And then what we have to do next is differentiate the power. When we differentiate the power, we get minus 3. And don't forget, negative 3 we cannot multiply with 4 here. We have to put at the front. And so we get minus 3 ln 4. And then the last one, please don't forget to put plus c. Plus c. Okay. Next. Integrate, example 4. Find the following integrals. Integrate 2 over x dx. Integrate 2 over x dx. Okay. Maybe you can try it first. I'll let you try it first. What to do? First, we have to bring out 2 in the front integral symbol. That means to integrate 1 over x. And then when we bring up, x become x power of negative 1. That means we have power minus 1. Power minus 1. Here are the answer. So when we integrate 1 over x or integrate x power of minus 1, we're going to get ln x. Ln x. So 2 times ln x plus c. This is the answer. Simple, isn't it? Okay, next. Integrate 1 over 5 minus 3x dx. 1 over 5 minus 3x dx. In basic rules, we don't have in the form of 1 over fx. Power of 1. if we bring up 5 minus 3x, it will has a power of minus 1. Power of minus 1. So power of minus 1, that means we can use the basic rule number 2. If we use it, there's no answer. Yeah. Okay, so what we have to do? Yeah. So it's same like we did the question A. Yeah. That is integrate to 2 over x. Integrate 2 over x. Yeah. So we understand that 5 minus 3x is a power of 1. Yeah. Then when we bring up, you're going to have minus 1. Yeah, the power will become minus 1. So when we integrate, it will get ln 5 minus 3x. And then don't forget to divide by f prime x. That means we differentiate 5 minus 3x. So we get minus 3. So the answer is 1 minus 1 over 3 ln 5 minus 3x plus c. Yeah, plus c. Okay, next. Yeah, next. Yeah, please screenshot if you don't understand how to solve this one, or maybe you can ask your lecturer after this, or teacher. Okay, the next one is integration of a function. The integral of f prime x over fx. Yeah, integral of the function. That means we have to look first what we want to integrate. Then if the integration in the form of f prime x over fx, f prime x over fx, integrate that one, we get ln fx plus c. So you can look for the previous knowledge previous knowledge about this differentiation. Okay, please don't forget if we integrate in the form f prime x over fx dx, we get ln fx plus c. Okay, so this one. Okay, next. Here are the example. Example 5. Find the following integrals. Integrate x over x power of 2 minus 1. Okay. If we look x over x squared minus 1, if you want to use in the form of f prime x over fx, fx here is x squared minus 1. X squared minus 1. If we differentiate it, f prime x, so we get 2x. 2x. That means if you want to use the f prime x over fx formula, that means we have to add 2 here. But if we only put 2 in front of x, we already changed the question. Because of what? The question is x over x squared minus 1. If we put 2 here, because of what? Because we want to make it as a f prime x. F prime x here. So that means we already changed the question. So what we have to do is, when we want to make it become a f prime x, that is 2x, we have to multiply the function given here with 1 over 2. So 1 over 2 times 2 become x over x squared minus 1. So first we have to make it a form like f prime x here. So the solution is like this one. So for the numerator, we look here is the f prime x. F prime x. So if we forget to put 1 over 2 at the front or multiply with 1 over 2, we already changed the question. So that means we are in the wrong step. So what you have to do is multiply with 1 over 2. Here is 1 over 2. So 2 divided by 2 is equal to the question. And then we applied the formula that is, what we get is 1 over 2 times ln x squared minus 1 plus c. Yeah, please remember this one, because we want to use the formula f prime x over fx. Yeah, f prime x over fx. Yeah, f prime x. Yeah, we already differentiate to the fx, and then if it's different with the question, please multiply with something. Let's say this one is 3x, so 1 over 3. If this one is 1 over 2, so multiply with 2. Yeah? Okay, next. So this one, it's quite difficult, but if you understand what I've just said just now, so you can solve this one. So please write down what is fx. Fx is 2x cubed plus x squared. Yeah, fx is 2x cubed plus x squared. If you differentiate this one, what you get? You get 6x power of 2. 6x power of 2 plus 2x. Yeah, 6x plus 2, 6x power of 2 plus 2x. Okay, that is the f prime. If we put f prime here, we get 6x power of 2 plus 2x. But why this one become 3x squared plus 2? That means we have to multiply 2 in the front to become numerator is f prime x. Yeah, the numerator become f prime x. See, if we multiply with 2 at the front, yeah, we already changed the question. So what we have to do is we have to multiply all with 1 over 2. Yeah, put 1 over 2 at the front. Okay, so I hope you understand about that. Okay, here are the solution. Yeah, so fx is 2x cubed plus x squared, and then when we differentiate fx, we get 6x squared plus 2x, but we already changed the question. So that means what we have changed, we multiply question 3x squared plus x with 2. So we have to multiply 1 over 2. 1 over 2. So the solution is 1 over 2 times ln to the fx plus c. Yeah, plus c. Okay, next. Integral form of f prime x times e power of fx. Yeah, so this one. And just now is f prime x over fx, but this one we have to make sure the form is f prime x times e power of fx. Okay. So when we differentiate, please remember, when we differentiate to e power of x, so we get f prime x times e power of fx. Yeah, please remember this one. And then when we differentiate in the form of f prime x times e power of fx, and we get e power of fx plus c. Yeah, plus c. Okay, next. So maybe there is a example after this. Oh no, the integral of no. Okay, here the example. Example A, integrate e power of fx dx. Integrate e power of fx dx. See what we get here? Yeah, the answer is e power of 5x over 5 plus c. Oh, how come? Yeah, first look at the fx. Fx is 5x. When we differentiate it, we get 5. Yeah, if you want to put 5 in the front of e power of in the front or the coefficient for e power of fx, 5 in the front here, that means you already changed the question. Yeah, you already changed the question. So what you have to do is multiply with 1 over 5. 1 over 5 is multiplication to the. So 5 here, yeah, actually we add it to become of the form f prime x e power of fx. And then, yeah, if we get the form of integrate f prime x e power of fx, so we have to, the final answer is e power of x over 5 plus c. Yeah, please understand what I said. Okay, next. This question is quite seems difficult if you understand about what I said just now. Yeah, if you look to the power of e, that is x cubed plus x minus 2. Yeah, you can write down fx. Let fx is equal to x cubed plus x minus 2, and then you differentiate it. You get 3x squared plus 1. So that means the question that given at the front, the question given is 3x squared plus 1. Here is f prime x. Yeah, f prime x. So that means we do need to change the form of the question, so we can get the answer directly like this one. Yeah, because the question given here is the f prime x. F prime x. Here is fx. Here is f prime x. So the form is actually integrate fx e power of fx. So the answer is e power of x cubed plus x minus 2 plus. Okay, dah. Okay. Sorry for the interruption. Yeah. Okay, I repeat it. Okay, when we integrate in the form of f prime x, f prime x times e power of fx. Yeah. So we can use directly the formula. Yeah. So e power of x, e power of x power of 3 plus x minus 2 plus c is the answer. That is the answer. Okay. Yeah, please screenshot. Next. The integral of f prime x times with fx power of n. Yeah. Okay. Fx here has a power. Fx has a power. Okay. So in the differentiation, when there is a fx power of n plus 1, we differentiate it, we get f prime x times this fx power of n. That means for the integration, we have to reverse it. Okay, so this one, integrate f prime x times with fx power of n dx. So we get fx power of n plus 1 divided by n plus 1 plus c. Yeah, plus c. Okay, next. Okay, for example, 7. Find the following integrals. A. Integrate x squared third x cubed minus 5 dx. Yeah, x cubed minus 5 dx. What is fx? Fx is x cubed minus 5. That means has a power 1 over 2. Has power 1 over 2 here. That is set here. That means fx has power 1 over 2. Okay. So if we differentiate fx only, yeah, so we get 3x power of 2. 3x power of 2. If you want to apply the formula f prime x times its fx power of n, so fx, if you compare here, there is no 3 here. And number 3, there's no number 3 in the front. X power of 2. So that means we have to put 3, and then don't forget to multiply with 1 over 3. If we only put x power of 2 in the front, x power of 2, there is 3 only. That means we already changed the question. So here it is. Okay. Yeah. This one is f prime x. But there is a number 3, or the coefficient x power of 2 is 3. Then we compare to the question. It completely different. And then what we have to do is multiply with 1 over 3. And so we get f prime x times fx power of n. Power of n. So next is we integrate based on the formula where fx, power 1 over 2 plus 1, we get 3 over 2. And then divide with the power. 3 over 2 plus c. Then we simplify it, we get 2 over 9. 2 over 9 x cubed minus 5 power of 3 over 2 plus c. Yeah, please don't forget, you want to change the form of the question, and make sure it's same as the question lah. Okay. Next. Integrate 2x squared minus 3 power of 4. What is fx? Fx is x squared minus 3. Here is x squared minus 3. When we differentiate it, fx only, not include with the power here, outside power, we differentiate to the fx inside the bracket, so we get 2x. That means the question given in the form of f prime x fx power of n. Yeah, we don't have to multiply with this number. So here we have here. So 2x x squared minus 3 power of 4 dx is equal to fx power of 4 plus 1 divided by 4 plus 1 is equal to 5. Yeah, plus c. So here is the answer. Okay. Next. Oh, end of lecture 1. Thank you for watching. So for the next lecture, please study for the 1.2. 1.2. On Tuesday, we will live again using the KMKK official channel. Yeah. So thank you for watching. Jangan dah jawab ke? Beritahu dah tadi. Nama? Example 6. Okay, there's a question about example 6. Yeah. Number 6. Which one is number 6? Why we have to divide with 5? This one. Yeah. From Irdina, if I'm not mistaken. Irdina Ismail. Yeah. Irdina Ismail. Okay. Okay. So the given function fx, what is fx? Fx is e power of 5x. E power of 5x. Okay, we look first for the rules maybe or formula. Yeah, so this one. Okay. So if we differentiate, please recall the differentiation. If we differentiate e power of fx, yeah, e power of fx, yeah, we get e power of x times with f prime x, yeah, times with f prime x. So when we integrate in the form of f prime x e power of fx, integrate of in the form of f prime x e power of fx, we will get what we differentiate. The function e power of fx. Yeah. Okay. If we look for the question, if you want to use or make it same as the form f prime x times e power of fx, yeah, f prime x times e power of fx. That means fx we have to differentiate first, lah. When we differentiate it, we get 5. The question is number 5 is not exist. Number 5 is not exist. So we have to put 5 to the front e power of 5x. Why? Why you want to make it become as f prime x times e power of fx. Okay, please understand this one. So when we put 5 in the front, we already changed the question. So to make it same as question, we have to multiply it with 1 over 5. 1 over 5. That means the question here, we have to change the form. The form what? We have to put at the front is 5, but when we put in front 5, we already change overall the question. When we change overall the question, we have to make sure that it's same as the question given. So we have to multiply with 1 over 5. 1 over 5 times 5 is equal to e power of 5x. Okay. So that means here, yeah, actually the question is kena tunjuk lebih lagi lah. Yeah, in the front we put 5 and then 1 over 5. So that means we integrate 5 e power of 5x. 5 e power of 5x. That means f prime e power of fx. At front we have 1 over 5. So we get e power of 5x. So that's why there is 5 at the bottom or the denominator. Okay, hopefully that will answer your question, yeah, to understand more. So we will meet again on Tuesday. Yeah, sorry for what I've maybe there is a mistake. Yeah, or maybe my explanation is not quite clear. So yeah, see you on Tuesday. Okay, thank you. Bye.